This is going to be a very basic explanation of Coulombs law, which once you see the form of the equation, should look fairly familiar to you. Coulombs law is an equation, and it's the force, so we're talking about forces, K, Q1, Q2 over R squared. This should look very much like the gravitational force. Remember, we had this at the beginning. G, M1, M2 over R squared. So again, K is a constant, just like G was. Q1 and Q2, instead of being masses like they were in Newton's law of universal gravitation, are charges. So our Q's are charges. And again, the R is the distance between the two charges. So the value for K, we're going to use the nice easy round number. It is a constant. So it's 9 times 10 to the 9th. And it has icky units, mainly just to cancel out all those other units. Newton's meters squared over coulombs squared, because we measure charge in coulombs. So let's kind of look at some of the relationships shown in this equation. So here's our equation, and basically what it's telling us is that the force is proportional to the charge. So if I double one of the charges, it's going to double the force. If I double both of the charges, I'm going to have to multiply that. So I doubled this one, and I doubled the other one, and so that's going to make my force 4 times bigger. So if I double one charge, then my force doubles. If I double both of them, the force is multiplied by 4. Okay, and that's because we have 2 times 2, so it's 4 times bigger. If I double the distance, okay, this one's kind of tricky. This is the inverse square law, because notice how r's on the bottom, that's like 1 over r squared, so it's like the inverse of the square. So if I'm going to double this, I have to square that, so that makes that 1/4 as big. So if I double the distance, my force is 1/4 as big. So a lot of times with these charges, let's look at what those are usually given in. Okay, the SI unit for charge, you should have this from your vocabulary definitions. The SI unit for charge is the coulomb, named after Coulomb. How about that? And it's abbreviated with a capital C. Don't get it confused with because it's not going to go in for C's as a variable. It goes in for Q's. So the variable, remember on our equation sheet we had the variables and the units. The variable is a Q, not a big Q like heat, little q. Sometimes you will see it with a big Q, and that's when they're talking about a certain charge. So you have to kind of be careful when you're looking at the equations. But a coulomb of charge is a huge amount of charge. It's huge, 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 huge. And so a lot of times we're talking about micro coulombs. Okay, remember the prefix micro means 10 to the minus 6. So if I have 6 microcoulombs, that is 6 times 10 to the minus 6 coulombs. And sometimes I might be talking about nanocoulombs. Okay? Remember, nano, negative 9. So if I had 6 nanocoulombs, that's 6 times 10 to the minus 9 coulombs. So you are going to have to standardize your units and change your micros and your nanos to plain old coulombs. Let's just do one example really quick. Okay, so we have two little charges. We have a positive 6 microcoulomb charge and a positive 4 microcoulomb charge, and they are separated by 4 centimeters. That's basically what we're talking about. And we want to be able to calculate the force. Alright, so K has a value, and it's always constant. We're going to use the same equation. So K is 9 times 10 to the 9th. Alright, Q1, it doesn't matter which one you call Q1 and which one you call Q2, because commutative property of multiplication, you can multiply them in any order you want. So we'll just put them in the order they're in. Okay, remember we need to change our microcoulombs to coulombs. So 6 times 10 to the minus 6 coulombs times 4 times 10 to the minus 6 coulombs. And we need to divide by the distance. It's in 4 centimeters, so we need to convert that to meters. That's 0.04. And again, don't forget to square that. That's going to be a huge, big deal to remember. So let's see what we get when we do that. So that comes out to 0.0135 newtons. And it's newtons because we were calculating a force. And remember, forces are measured in newtons. So that's kind of what you're looking at. Sometimes you might be solving for R. Sometimes you might be solving for the charge. But you're basically going to be using this equation. We have the second question here. And the question is it attractive or repulsive? Well, what was the sign on our two charges? This was positive, and this was positive. So, what do you think? They have the same charge, so they are like charges. Opposites attract, so like charges repel. All right, so that was easy enough, and I think you should be able to do it. Okay, if you have any questions, ask during class. See you tomorrow.